This conference will now be recorded.
Good morning, everyone, and welcome to the ICG's Digital Academy webinar series. I'm Sally Alsop, the ICG committee member responsible for our webinar program. So for today's webinar, we're delighted to welcome back Phil Barden and to welcome for the first time his colleague, Dr. Dirk Held. Dirk is co-founder of the Decode marketing consultancy based in Germany and also AimPower, Decode's sister company that specializes in AI. He's one of the leading experts in translating scientific findings into actual marketing practice. Author of several best-selling books on the topic of neuromarketing, advises international brands on how to optimize their marketing activities. Dirk has a degree in psychology, an MBA, and his PhD in behavioral economics was about the influence of brands on purchasing. His most recent publication was the book AI in Brand Management. Phil Barden is Managing Director of Decode Marketing Limited. After 25 years in client-side brand management for Unilever, Diageo, and Mobile, Phil became a client of Decode. The impact of their behavioral science approach on T-Mobile's relaunch was so commercially successful that Phil quit to join Decode and set it up in the UK. Author of Decoded, Science Behind Why We Buy, and a Fellow of the Marketing Society, Phil works with many clients and agencies in the application of behavioral science to day-to-day brand and shopper marketing activities. So during today's webinar, Phil and Dirk will be describing what AI is and how it works from a marketing perspective. They will share some marketing-related use cases, explain what are its limitations, and how to judge where and how AI can or can't help. Phil and Dirk are happy to take questions as they go along or at the end. So if you'd like to ask something, raise your hand, turn on your webcam, raise your hand, or type your comments or questions into the chat box and we'll put them out for you. So this webinar is generously sponsored by Qualzy. The platform supports all your asynchronous project needs, including diary tasks, UX research, video blogging, international projects, long-term communities, and much, much more. Click the QR code or follow the link to claim your exclusive ICG discount. Qualzy are passionate about quality insight and love working with quality researchers. They look forward to making friends with more ICG members and helping you to deliver more for your clients. So before we hand over to Phil and Dirk, here are some more events that we've got planned for you over the summer. A busy timetable. Don't forget that we're able to offer great value sponsorship opportunities with each of our webinars and online events. And all you have to do is to contact Lucy if you want to know any more about that. So now I'm going to hand over to Phil and Dirk. If I can find Dirk, there we go. Presenter, over to you, Dirk.
Okay. So, hi everyone, you see my screen, is that correct?
Yep, that's it.
Okay, and you hear me okay? So, yeah, happy to be here. As you know already from the introduction, I'm not a native speaker. I try my best, yeah, I would like to make that an interactive session. So whenever you have a question, you jump in, but I will also kind of make some pauses in between, so you can raise questions. So it's a more interactive thing. So Phil and myself here for you to and try our best to answer all the questions around the AI and how to use it and what the limitations are, because that's the kind of overview. So let me know how. Okay. So maybe a short introduction for Phil and myself. As already mentioned in the introduction, Decode and myself, so I founded Decode together with Christian Schreier in Germany, Phil in the UK, and I also founded that sister company, AimPower, which focuses on evaluate asset effectiveness, especially for companies, and you see some of the companies that we work with. Now, what is the agenda for today? So what is AI, how to think about it, and how does it work? What are the use cases? what are the limitations, and how to judge when how AI can help or not, right? So that's the piece here. Now, what is AI? Let's directly jump into that. So first of all, what we all know, AI is all around. We all know it is disruptive for everyone, and it continues to be disruptive. Sometimes it's referred to as the fourth industrial revolution. And there had been other, obviously, industrial revolutions before, but what is unseen in this case is the speed, right? So normally you have developments, there is a patent out there, and it takes time. You need infrastructure, like if you think of the energy, or the steam machines or electricity, that all took time. Here, the infrastructure is already there. It's the internet and PCs. Everyone has it. And most importantly, the technology as such is not patented. So the algorithms are open source. Most of them are just published by universities. And with that, everyone can use it. So that's why the speed is so incrementally high. So it's not only disruption, it is also a very, very fast disruption. And of course, we have an AI versus human discussion that is more on an ethical and societal level, which is of course something, and also of a legal level, which needs to be done, of course. However, and there is of course a lot of AI washing. So some clients report that some vendors go out there and now a normal regression analysis is AI washed being machine learning, right? So that's why I think it's good to know what it is about. But of course, the focus today is really concrete examples of application. So we will not very much focus on the societal aspect of it, not to degrade this discussion, but today the focus is on examples of application, if that's okay. So first of all, first and foremost, one thing we really need to understand, because in all the communication and in the media, they always talk about the AI, but there is no one AI. It's not a software you can install and it does whatever. So ChatGPT, which is something everyone now, even my kids, heard about, even this is very universal in nature, because what it can do can be applied to a lot of use cases. However, it's only text at the moment. It doesn't process sound, for example. So every AI is use case specific, and it's trained on a specific use case. And depending on the use case, you have a specific data set. Now, if the data set is rubbish, the AI is rubbish, garbage in, garbage out. And so, but it needs to be done use case per use case. So for example, if an AI is able to recognize or to identify a dog, a picture of a dog showing a dog, it will not be able to recognize a cat, right? It can only say, well, this picture of a cat is not a dog, but it doesn't know, it cannot apply the label cat because it hasn't been trained on it. So it's very use case specific. So therefore, any AI or any model that is used needs to be evaluated. What was the data that went in there? For which use case is the result generalizable and usable? That's very important to know. There is not one big AI in place. Now, what is AI? It's always good to start with a definition. I don't know how familiar you are with the whole terminologies. That's why for those who are very familiar with it, sorry for being redundant and maybe a little bit superficial, but I just want to make sure that the kind of key, that they were all on the same page. So first of all, what's the benefit here of using AI? First of all, because of automation. So it makes things faster, cheaper, and you can use it at scale. That's the kind of overall overarching motivation behind that. Now we have, first of all, we have machine learning as a technology. So some of the models that are used are based on machine learning. Machine learning is based on the so-called feature extraction. So imagine you have a text. For example, you do a qualitative interview and you use AI, for example, to transcribe automatically all the interviews, to have the text written down and nobody has had to sit there and transcribe. Now, first of all, you can extract features from that text. For example, how much words do they use? Is the language active or not? What is the sentiment in the text? Is it positive, negative? Do they use personal pronouns, or whatever the text features are? So the machine extracts those features, and the model is then based on these features. Deep learning, on the other hand, is a little bit different. For example, to give the same, to stick with the same example, you interview some people and you also ask them whether they purchase it, yes or no, right? And so you have a dependent variable and an independent variable. So in a deep model, what you do, you hand over the complete text to the machine together with the result of the purchase interest question, and it will create a prediction model. So when you provide the machine a new verbatim, it can predict the purchase interest based on that verbatim. But that's not based on machine learning, because you don't extract the features. You just hand over the complete text as it is to the machine together with that variable, and it will create a deep learning algorithm that at the end of the day creates a model that can predict the dependent variable, in this case purchase interest, but without any features, or you don't know why. It's quite kind of a black box. It just spits out a prediction, but you don't know exactly why. So that's deep learning. And then we have the generative AI, which is generating sound or images or videos or text, right? So that's the basic technologies behind that. And now the question is, how does the training work, and what about validation, right? Because that's always the first question. How valid is it? Now the validation piece becomes a little bit more clearer if we talk about how an AI model is trained. And it's trained based on a so-called 80-20, sometimes 70-30 rule. So you provide the machine, so you have data. Let's say you have 1,000 interviews, or you have 1,000 pre-test, or whatever it is. And then you hand over 80% of that data to the machine in order to learn. And then you take the 20% of the data in order to test whether the prediction is accurate enough or not. So therefore, validation in the classical sense is part of the training process. The more important question is, how accurate is the prediction, and can I generalize from the data with which the model was trained to my use case? To give you an example, we use an AI model that predicts where people look. So it's trained with human eye tracking, and it can predict with a very high accuracy where people will look at. Now, for one client, they wanted to use that for their shelf layout, so in store. They want to analyze whether that model can be used in order to predict where people will look at. Now the question is, the model that we use is not trained with shelf data. Now the question is not whether our model is accurate or not. It is. The validation is part of the training. However, the question is, can this model be generalized to that specific use case? So what they did, they used our model and their eye tracking they did with shelves, tested it, came to the conclusion that yes, that's accurate enough even for that use case. So I can generalize the model to that use case, and then they rolled it out. So it's really not the validation, and the validation is part of the training, but it's more how accurate is it, and can I generalize what the model does to my use case? That's how to think about validation. Is that does that make sense for you, or is that, because I think that's a critical part when it comes to the question, when can I use this model, and when cannot this model be used? All good? Oh, okay. So the key point in setting up AI models is really the training. That's 70 to 80% of the time. The training as such takes some days, maybe weeks if it's really huge, but normally it's the training itself is not the issue. And then there's the question of, is the data biased? Now, if the data is biased, the machine will learn the biases. And that can be a bug or a feature. So one use case is to predict, given a certain CV, whether people are going to be invited for an interview, so HR use case. Now, and that's based on the past, right? So they had certain CVs, they gave it to the machine together with the information whether that CV, so that person, got an invite for an application interview or not, right? That's the dependent variable. Now, if that decision, which is based on human decision making in the company, is biased, for example, similarity bias, racial biases, whatever the biases are, the machine will learn them and pick them up. But not because the machine is racist, it's because the decision of the humans that are provided to the machine to learn it was biased. Now, in the case of consumer research, this bias is not a bug, it's more a feature, because human decision making is biased. And in this case, we want to learn those biases if they are systematic. But if they are not systematic, the machine will not learn them, because obviously it's not a pattern, it's random. But if it's not random, if there is a pattern, we want the machine to learn the biases. So for example, because I use that example because it's so easy, in the case of attention, we know that humans have the bias to prefer faces over other objects in a picture. That's a bias. However, in order to predict the attention of humans, we want the model to learn that bias, right? So in this case, learning the bias is a feature. Again, it's all about what is the data that is put into the machine to learn it, and not so much is the model that's resulting the problem. Data creation, that's the problem. Dirk now answered your question, Kevin. Oh, sorry. Okay, you jump in. You interrupt me whenever, right? So at the end of the day, what the machine is doing is this basic question of y is a function of x. So it learns the function. Now, the thing is, if the machine learned the function that applies a y to an x, it can go both ways. So that explains why a machine, once it understood to recognize and to classify a dog, which is, you have a picture with certain features, this will make, let me go. So you have a picture of a dog. This picture has certain features. Now, based on that function, it can predict whether this is a dog, yes or no. On the other hand, if you give the machine the class, the input so the Y in this sense, dog, it can produce the features. It has learned what features make a dog, and then it can create a picture of a dog. But at the end of the day, it's Y is a function of X in both ways. And since a machine is based on numbers, the key point, which is called embedding, is that any sensory input can be translated in a string of numbers. And once a machine has numbers, it can calculate with it. So, and in a very basic sense, it's nothing else than that. So you translate certain features into numbers, and the machine learns a function, a Y equals f of x function. However, that function is very, very complex. So that's the only piece that is new. But from a principle standpoint, that's it, right? And the algorithms behind that, of that functions, they are not very new. So many of those algorithms are in place since decades. However, we didn't have the calculation power and we didn't have the data to really leverage those algorithms. But from a programming standpoint, that's not very fancy. That's quite straightforward, but it's the data we put in there which makes it so powerful. Now, why is a lot of, everyone has came across the ChatGTP. What is it that made ChatGTP so powerful? It was, you have two aspects. One is, of course, the size of the model. So with how many data has it been trained? But there is one point that shows that the more data you put in, the value you get in terms of accuracy is decreasing. So if the next has twice as much data as ChatGTP, it will not be twice as good as ChatGTP. So there is a degressive curve. However, what really made ChatGTP so powerful is a reinforcement learning. So the machine created something, and there were humans giving feedback to the machine whether that was a helpful outcome or not. And they only used, and that's the dramatic piece here, they only needed 400 hours of human labeling, so-called human labeling, to boost the accuracy and the power of the model. So that's what's called reinforcement learning with human feedback. That is what gave it the power, right, over the other models before that. And is there any questions we should ask? We should answer now? No, all good. Okay. Now, in our case here, marketing, consumer research, we have three players. We have consumer, we have the domain expert and the user of the AI, and we have the AI, right? Just to make it very simple. It's a simplification, of course, but I think it helps. Now, if we look into the marketing, into the across the marketing process. So first of all, we have the data collection, where of course machine can help. However, consumers or this data needs to be provided or created by humans, by consumers, either via a primary research, so qualitative or quantitative primary research, or secondary data, which is they post something, they comment something, they create a video on TikTok, whatever it is, so they create data. Now, there are two ways we can use that data. First of all, we can use this data to train predictive models, AI models. However, and that will be increasingly interesting going forward, it can also be used to train digital personas. So there are first attempts that they built a digital avatar, a kind of digital character, and you can, for example, interview that character, and the answer that character gives is very valid to the answers that a certain target group is giving. I know that sounds a bit spooky. However, if there is a pattern in a certain target group and we have enough data of that target group, you can build that digital persona and ask that digital persona. So you don't need the actual consumer anymore. We come to the we come to the limitations, of course, because if something is happening, for example, Corona, you know, a model is always backward oriented. That means trends, new needs, new technology is not yet in the model, and therefore your digital persona would be out of date. Outdated, I think, is the English expression. It would be outdated. So that's, of course, is a big limitation, but from a technology standpoint, those are the two things you can do with it, is predictive models and digital personas, right? The ideation and strategy, so you have the data, you analyze the data, but then you take something out of the data, that's the human. So strategy and decisions need to be done by the domain expert, by the marketeer or by the researcher, wherever it is. You can use AI to give you inspiration for how things look like. I show you some examples in a second. And of course, the AI can create or co-create assets. So the touch points, the actual touch points, whether it's packaging or a video or whatever it is, an email, text. And of course, the evaluation of effectiveness can be done by the AI, of course, only if it's based on human truth here, right? So here again, consumers, they train models, and if that model is trained, it can automatically evaluate the effectiveness of assets. So that's the kind of how those players along the marketing process appear. And of course, AI is increasingly taking parts of the pie in every step. Does that? Yeah. Was that a question? Yeah.
Yeah, we have a couple of questions for you. Going back to the previous slide, I think this was, with the human feedback, was it a case of correcting errors only or inputting new data? So
both. Both. You can either, you can, so in ChatGPT, in the case of ChatGPT, it was a correcting feedback. So right, the ChatGPT scraped the internet, so to speak. So dumped all in that big model. And then the human was used as, in this case, to label data, which means give feedback whether the prediction that what the AI generated was helpful, yes or no. So it was a more correction function, that reinforcement learning. Was that the question?
Does that answer your question, Simon?
Okay.
Yeah, clear. Okay. And then he's saying, this is what I meant by future of qual being to be the reality check. I don't know if you have any comments on that.
Yeah, I do have an example in just a second. Yeah. Digital personas, I cannot read it, it's too fast. So there was an digital persona avatar question already also.
Digital personas with avatars could then be interviewed, I guess, and generate verbatims.
Exactly.
Yeah.
Yeah.
Okay. I think that's it for the time being. So do carry on.
Okay. So, well, first of all, data collection for insights. I think that's interesting. So you can collect automatically images, videos, voiceover, and text and sound. And of course, you can use those algorithms to efficiently analyze this big data, whatever it is. So transcription of interviews, cost-quantity analysis, an automated coding of verbatims. We have one client, they have a tool. They do qualitative interviews, but they only have one tool to transcribe it. And then auto-code it. Right. So that's one very basic application here. And the sources can be Amazon reviews, website, blog, social media, whatever. Whatever is right for your use case can be collected as long as it's legally okay and as long as it's accessible. right? Then it's those are the sources you can use. In this case here, we scraped with Instagram the hashtag good life, and then we tagged automatically the pictures, and we saw what kind of topics are people photographing when they post something in the hashtag good life, right? So you have luxury shopping, nature. This is, sorry for that being German. So it's luxury, it's nature, it's conviviality, so being together with others, culture, food, and other things, right? So with that, you can have a big data, but still it's a kind of qualitative, also qualitative analysis in the sense of what kind of topics is it that people talk about here. That's one use case. This use case here, that's exactly the point of what is the role of qualitative. So here I used ChatGPT-4, and I wanted them to tell me the 50 benefits and features consumers seek from a laundry detergent, right? And I wanted to sort it, the answers by importance. And what you see is that it makes sense, right? And the only reason I know that is because I'm somehow a domain expert in laundry detergent, because I'm doing research for clients since 15 years on detergent. So that is a very good list of things. And then I tried, because I know that Mexico is a little bit different. So I asked GTP which of those benefits are especially important or on top important in Mexico. And again, very plausible. You have cost effectiveness because of the crisis of living. They want to have foam. Why? Because they use detergent also on the floor and for other purposes. And then here the multi-purpose scent. Mexicans are very into scent, you know. So even this is very plausible if you are already a domain expert. But if you are not a domain expert, you don't know whether chat is right or wrong. That's not a Wikipedia. So it's just a plausible based on a probabilistic prediction. But whether it's really true or not is a totally different question. We don't know. I know that this is true because I did the research first and I'm already a domain expert. So we cannot just believe what chat gives us because it's hallucinating. It's a probabilistic approach. That's something to always keep in mind. However, as a starting point for research, or in order to accelerate the qualitative research, it's of course a great starting point and great hypothesis. And then I did something. I wanted to understand the differences of the brands Nivea and L'Oreal because they are very different from a social and emotional benefit point of view. And again, so for example, Nivea, it learned that it's more about gentle care, and L'Oreal is more about glamour and luxury. That's not trivial. However, we know that this is the case, but it shows that how much it learned. But again, if you're not a domain expert and you just take that, it might be wrong. Yeah.
So, Dirk, we have another question for you. Does it have access to proprietary research by brands? And if not, is that not a huge limitation?
Yeah, well, it does not, because it would be illegal, right? However, what the companies do at the moment is, because they don't want to use the ChatGPT official thing, because then their data is going to be used in order to make ChatGPT better. You don't want that. So what Microsoft is currently thinking about is to give them a ChatGPT version in their system, so they can use and play around with their proprietary data without it spilling over to the open source model, right? Because there is a legal issue here. But the other point is, once you have ChatGPT as a kind of starting point, you can then use your proprietary data to make it better and more specific to your use case. So that's something, for example, JP Morgan did. They used ChatGPT but then they fed it with all the documents of their company, and then had a chat system that is really not fine-tuned, because fine-tuned is the wrong word, but it has been specifically set up based on chat, but it was specifically created then to deliver that use case. So that's the way how you do that. You use chat as a technology, as your starting point, and then make sure it fits your use case. That's the way how the companies do it.
So somebody's made the remark, Azure OpenAI in a sandbox.
Pardon me?
Azure OpenAI in a sandbox. Does that make sense to you?
Yeah, but I'm not. That's something. The sandbox. Give me one hint on the sandbox. I'm just not. What
Jeff,
do you mean?
Jeff, do you want to come in on that?
Give you.
Companies are using MS within.
I think a sandbox is like a walled garden, so it's a proprietary internal system.
Yeah, that's what I was referring to. Exactly. So that's they're currently working.
Azure OpenAI is a good example of Microsoft providing that to specific companies so that they can work with it within their internal network, so it's not external. Yeah.
Exactly. That was my point. Yeah. Exactly. Yeah, and that's and of course currently Microsoft is going to include it into their Office products as their what they call Copilot. So to make it very very tangible to use it. Yeah, so very easy to use it. Now, co-creation is something that's the whole generative AI piece. So this, for example, is one example. So you use language. Those models are called a model or multi-model. And with model, I don't mean many models. What I mean is many modalities, which is picture, sound, and language. So here the prompt, so the input was an armchair in the space in the shape of avocado, imitating an avocado, and that's what the machine generated based on that prompt. And that's of course a very nice inspiration. You cannot use that because the domain expert can need to understand whether is that even possible, feasible from a production and supply chain standpoint, whatever, right? That's something the machine doesn't know, but at least you have a very good starting point and some ideas. The same point with the Nutella. I don't know if that was available in UK as well. Over 3 days, an AI created over 1 million of those packaging designs. And then the team of Ferrero and the agency then selected those what they want to put on the pack on the real products. Of course, we have that even with the videos or the so-called deep fakes, which is nothing than a generative AI in this case, or that this is called style transfer. So you have a picture and you give it a certain other prompt. So for example, you have a picture and you are Nivea and you want to make that look more natural. It will create a different picture that merges those two things. That's called style transfer. So there are a lot of ways how you can use AI to inspire or co-create and in the future even create. However, the creation, there are some legal issues. At the moment, there are some legal, do you say legal suits, legal Verfahren, Phil, if you help me, some
legal cases, yeah, cases
in the US because of who owns it, whose data was used to feed the model, and therefore what's my propriety. Those are some legal issues that are currently discussed as well, and that's why.
Sorry, we have a couple of questions for you, Dirk. On what platform can you use style transfer?
Oh, there are a lot. If you type in style transfer, there are a lot of tools offering that.
Okay, and there's another question. So what is the source? I think this is going back to the Nivea versus L'Oreal. What is the source? This the source of GPT's outputs for Nivea versus L'Oreal outputs, if not proprietary research? What is it referencing to come up with these outputs?
Well, what it did, it took the whole internet as text. And what all the language models do is it's a probabilistic model. That means every word is represented as a number. And this number is based on all the other words around it. That's called nearest neighbor or co-occurrence. So what is the likelihood that the term care occurs when Nivea occurs? If that probability is higher or very high, the model has a probability to say, okay, it's Nivea, and Nivea is care. Now, if you ask ChatGPT a little bit differently and ask, what is Nivea about? What is L'Oreal about? The difference will not be high. Why? Because they all are in the same categories. Now, and therefore they are all about skincare, for example, or hair care or whatever. So the differentiation is not high. But using the prompt differentiation, what is different is nothing else than you have a string of numbers for Nivea with all the probabilities of all the words, and you have a string for L'Oreal, and it only looks at those numbers, so those words that are different between those two strings. So it's really just a huge string of number, and you calculate with that. It's a pure probabilistical output. That's why it might be wrong. It's not a Wikipedia. There is no source. It was created based on a model. It created this answer. It did not retrieve this answer from somewhere. There is no source. There was data in the model, and that's maybe something to be very clear about. The model, once the model is trained, the model is no longer the data is no longer part of the model. It's out. The only thing that the model is capturing are weights, only weightings of numbers, but not the data anymore. The data is gone. You need the data to train. The model is learning the weights, the pattern, the probabilities, and then the data is gone. And what you see here is just a probabilistical assumption or a probabilistical output. It's created by the model. It's not retrieved from any source. Does that make sense? There are some questions. So
oh yes, there's another question. Does that data then influence the next model or regression then?
Only if this model is part of the next, if the data is part of the next model training. So because what you refer to is, what if we put something into that model, right? So first of all, in order to change the probabilities within that model, given the size of the model, if you put in 10,000 other texts, it will not change anything, right? That's a limitation, because it's the big number effect, right? It's a probability. If you change only a few things, given the size of the model, it will not change the outcome. So that's why if new trends come in, you need to, that's a limitation. It will not weight these things automatically high just because it's new, for example, right? So either you train a new model, or you really need a lot of data in order to shape an existing model, depending on the size. But that
There's another comment that's come in that says, I'm intrigued by how AI accounts for biases that occur due to some countries or languages generating far more content than others. So do the user cases need to be country specific to be more reliable?
That's an empirical question. It might be, it might not. But that's exactly why you need a domain expert in. If that's something, that's an empirical question. Because we don't know which data got into the model. And since we don't know it, we don't know whether that can be taken as, if we can generalize the outcome here to our use case. That's exactly the point I made in the very beginning. The problem here is in ChatGPT, we don't know the data input. We don't know what, was it also text from South Africa? We don't know. So that's an empirical question then. And that's where market research in the future will have its value to, first of all, check whether predictions are right, deliver the data, but also explore whether what the machine is doing, can it be generalized to my use case? And that's an empirical question. Does that make sense?
So another couple of questions, and then we probably better move on. Building on this, small differences or biases in the data used to train AI will become exaggerated in order to create plausible but probably inaccurate answers.
No.
And then can it only... Yeah, go ahead, answer that one.
If it's only small biases, it will not show up. Why should the model exaggerate small biases?
Okay, I don't know if Kevin wants to come back on that. Otherwise, Iona's asking, can you ask it to only reference certain markets? You talked about specifics for laundry in Mexico earlier, so could you get it to focus or?
It's an empirical question. Try it.
Yeah.
But it will spit out something. That's the tricky part. Whatever you throw at it, it will create something. But you need to have a domain expert in order to judge whether it makes sense what's created here. It is created. It is not retrieved like Wikipedia from a source. It's very important. But try it. So like I tried here with Mexico. And I know because I'm a domain expert that it makes sense. If I wouldn't be a domain expert and I take that for granted, it might be totally, it will always sound plausible. But whether it's right or wrong, you don't know.
Okay, we're running short of time, so I suggest we move on with your presentation, and then if there's time at the end, we'll go back to these additional questions.
Exactly. So, yeah, we covered all of that. Now, if we want to, so we had data collection, we had co-creation. Now it's about evaluation, right? How can we evaluate the impact of a certain something, be it a message on asset on the consumer? So two things: one is information processing, the other thing is valuation of a certain target group. So does it fit the need, and do they like it, right? So those are the two key steps in the brain: information processing, valuation. Now, if we go through that maybe a little bit faster. Attention, one of the information processing steps is attention. As I said, that can be trained with human eye tracking or based on human eye tracking data. You can check whether it fits, it can be generalized to your use case, and then you can deploy it. So that's attention. So that's quite solved. You can have any kind of KPI or analysis regarding how visual complex is it? Is it memorable? So for example, memorability is trained with human recall data. So how easy is it to store and recognize a certain picture? It's trained on human recall, and with that it can predict human recall. Right? Or legibility is something easy to read. How much time does humans need to read it? This is not even an AI. This is only AI is used to extract the text from an image. But then we know from neuroscience that humans on average can process around 4 words per second. So you take the number of words divided by 4. That's a very simple algorithm, and then you can predict how long it takes people to read it, right? So those are perception aspects you can automate. This is a use case in Thailand, a cosmetic brand in Thailand. They don't have money and time for pre-tests, so they up to that point they only got advertising tracking post-flight, so after they spent the media money, and then often saw a bad brand assignment. So we trained a model that is able to differentiate or to predict brand assignment of a TVC per scene. So those are scenes. So they can check and optimize the brand assignment prior to airing it, right? It's based on the model. So you have the brand assignment results, you have the TVC, you train a model, and with that you can predict which brand in which scene is likely to be, again, probabilistic, is likely to be assigned to this brand or another brand. That's branding as one use case. The other step in the brain is, what does it stand for? So semantics. And again, you can use this with pictures or videos or text. So in this case here, the model here is called CLIP. It's trained on picture text pairs, over 400 million picture text pairs. So you give it either a certain text, so a certain word, it will create mood boards and collect images that fit to that word, or you provide it a certain picture and it will give you back those words with the highest probability that it fits to this picture. Yeah? So with that, machines can also evaluate semantics, even in sound. Yeah? So picture, sound, and text. But most importantly, relevance and liking. Because first of all, what we just looked at is information processing. That's more or less not very different between target groups. Older people read a little bit slower than younger, you know, but normally information processing is quite hardwired. There is, yeah, so that's now, but relevance and liking are very target group specific. However, if we have data and we know which messages are relevant, we can train a model to predict how relevant is that message for this target group. It's just, if we have the data, then we can predict it. Now, if needs are changing, or if you have a new product that with a new benefit that no one ever had, that's a limitation because the model didn't learn that. So everything that is new is a limitation for a model that has been trained, built on historical data. That's a limitation here. Yeah. So that's something that if we have the data, you can train it. And there is one combination that we just as one use case. So this client, they did so they had their standard advertising pre-test. In that pre-test, they also included an open-ended question. So they had the data of purchase interest and all the other matrices they measure in that pre-test, and an open question for the respondents for each of the TVCs. Now what we did, we trained a predictive model based on that open-ended question to predict purchase interest. Right, so we had the TVC, well, we had the open-ended question, and we had the purchase interest, and therefore we trained a language model. Now what the client does is, this client uses now only one open-ended question. They don't do the pre-test anymore. They only use that one open-ended question, which is much faster and much less expensive. And then they predict the effectiveness in market. They also validated the prediction with real in-market behavior. So not only the claimed self-report service survey data, but also in-market sales data. They proved the validity of it, the accuracy of it, and then rolled it out in almost 20 markets now. So that's the, and the other part of it is the diagnostic part. So based on that open-ended question, they also use an automated coding of all those aspects that the consumers mentions in that one question. And they can deep dive in all the verbatims very easily. So they have the impact prediction, they have the diagnostics, and they can deep dive into the verbatims, and all based on one single question, which saved them a lot of money overall. So that's another use case in market research. So I've given the time, I think we skipped that. So we can optimize, we can control, and you can manage. Those are the big 3 use cases with it. And the limitations we already talked about: bad data, bad results, needs to be use case specific. So we need to check whether it's generalizable. Irony, humor, metaphors, very, very hard for a machine to deal with it. Trends and new behaviors and needs, if it didn't learn it in the data with which it was trained, you don't have a chance to pick it up. And of course, predictive models need to be maintained. So yeah, so I think, and from a market research perspective, I think it's key to learn how to leverage and cooperate. So for example, we have some partnerships with other market research companies in place. They use our capabilities complementary to what they deliver as a kind of a team approach in order to give the best possible value to their clients. So I think it will be a cooperation between domain experts, and you as a researcher are also domain experts, and the machine, and together I think they will provide better insights faster than to the clients. So that's I think the way it will go. And that's it from my end.
That was fantastic. Thank you so much, Dirk. I have a feeling we could spend a whole day on talking about this. It just it's clearly a subject of massive interest at the moment. I think we've pretty much run out of time. So unless there's a last burning question that somebody wants to ask Dirk or Phil. Ria is asking, in consumer market research, how can machine learning algorithms be leveraged to discover innovative and untapped opportunities beyond the scope of customer segmentation? Is there some new innovation one could come up with for this industry to make things easier?
Well, the one of course is on a design angle. You have all the generative AI, right? Like I showed on the here on the armchair example. Those could be, co-creation and inspire you. If it's about detecting new needs, for example, right, which is something we also need to understand. There are also ways to do that. So, for example, for one client, we collect product reviews, and we have a set of coding with it. But each verbatim that is not coded with what we have today as codes, so as benefit codes, is highlighted. And with that, you know exactly what are verbatims that don't fit to how we look at the data today. So the residuals, so those that cannot be coded with our current mindset. And then they look into it and see, are there any benefits that we don't think of today? If so, they include it into the coding and then see whether it's evolving, for example. So there are ways to also kind of detect trends, but there is no model as such saying that's going to be the new trend. Because if it's an AI model, it needs to be trained with historical data. You need to consumer, and you need to really think about how can I make sure if things happen that I detect it. But that's not trivial.
Okay, Dirk, I think we've run out of time, so thank you so much for that. Really, really interesting. Thank you also to everyone for logging in today. Do come back and join us. We've got another couple of webinars coming up on AI, so if that's of interest to you, do come and join us again. Otherwise, have a great afternoon, everybody. Bye.
Bye-bye. Bye now.